Powertrain Calibration, a Ford Motor Company. Ladies and gentlemen, please welcome Mr. Hammoud.
Good morning and welcome to our session. My name is Mazen Hammoud and I'm a recovering V8 engine enthusiast. I'd like to welcome you to this session entitled, I want to call it Replacement for Displacement. And now I gave the punchline for my talk. I think there is a replacement for displacement now. Like many of you who have worked on engines for years, I've been heard once or twice saying there is no replacement for displacement. America loves its V8 engines. What's not to love? It's naturally balanced, it's powerful, great towing, low-end torque, 0 to 60, has a great sound. It's exciting to drive. But fuel economy, not so much. So, as we develop our strategies for the future, like you've seen this one here, the blueprint to a sustainable future from Ford Motor Company where I work, downsizing has been an enabler for saving fuel, and its beauty is that it's attainable, it's economical, and it's relatively ready technology to implement. So as we outlined at Ford our methodology for getting to a sustainable future, downsizing and boosting was at the heart of the strategy, both in the near term as well as in the mid-term and more into the future. So our EcoBoost engines, which are direct injection turbocharged engines, started their production in the 2010 model year, and ever since they've been introduced in more and more versions of the engine and in more applications. So the reason is the bang for the buck that you get from downsizing and boosting. It's a great fuel economy gain compared to where we're coming from, and it doesn't compromise performance. So here's just a brief overview of how it works. I just showed the PSFC versus a torque curve. So to deliver the same amount of torque, if you look to the left of the slide, the region where most engines operate today, most of the time, you see that the PSFC of an I4 EcoBoost engine is a lot lower than an as-aspirated comparable power V6 engine in this case. And the same applies, I put on the screen here a picture of a V6 EcoBoost, the first one we introduced, and then a 2-liter EcoBoost, and now we're doing a 1-liter I3 started in Europe and will be the concept is the same, direct injection, turbocharging, and we use variable cam type. The key is we're operating the engine at a wider range near its peak efficiency. But you don't compromise performance. And the holy grail for any engine designer is a flat torque curve, and by definition here, because we get very quickly to near peak torque, and with controls we set the clip of how much torque we're going to produce from this engine. It looks a very flat torque curve throughout the useful operating RPM range. So EcoBoost provides, or direct injection and turbocharged engines provide fuel economy and performance. The question in the back of our minds, and most of you have been, but will the customer buy it? We knew that this is an exciting technology, and all it takes is for the customers to test drive it. Once they test drive it, they are sold on it. Well, we got a little help. With gas prices peaking in the 2007, 2008 timeframe, and then with a slight dip back, but they've been increasing again, it changed the mentality of the customer. The fuel economy became a reason for buying a vehicle. It was a purchase decision based on fuel efficiency. And when the customers gave it a chance, got in these vehicles, they were pleasantly surprised by the performance field of these smaller yet powerful fuel-efficient engines. And you've seen the numbers, you've seen the headlines, but this was one of the surprises to us too at Ford. The F-150 customer has always been a V8 customer, and we were very skeptical as to the acceptance of a V6, despite the performance and the attributes that we knew it could deliver. The response exceeded our expectations. Now, V6s in the F-150 outsell V8s. And this is something, a few years ago we wouldn't have predicted. The media obviously reacted accordingly. Like, this is some of the testimonial, and I'm not trying to do a commercial, please, for the F-150 or anything like that. This is just an illustrated example of the type of acceptance of these downsized engines that is now becoming a reality. Like, acceleration is almost diesel-like, and it's relentlessness, and the truck has more than enough in reserve for passing maneuvers, even with a trailer behind. I am a powertrain calibration manager at Ford, and a lot of my time is spent on the road, going to different altitudes, temperatures, and this is where the performance of these engines surprised even us, the professionals. Usually it's been accepted that as you go up in altitude or the temperature go up, the air density goes down, the power, the performance will start degrading. Well, the turbos compensate for that. You just compress the air more and get the right amount of air into the cylinder to produce the power that you want. And the dealers also were skeptical. How are they going to sell a V6 to a V8 F-150 customer? They were blown away by its performance and the acceptance from the customers. So with that, we put that technology and rolled out a strategy into i3 in Europe, starting in Europe, and now it will be coming to North America. And here are some of the testimonials. The difference between what I expected and what the 1 liter Focus delivered was, I kid you not, one of the greatest shocks of my career. And this is a journalist saying that. Similar comments on the Escape, which will be launched here soon in North America with a 2 liter EcoBoost and a 1.6 liter EcoBoost. And then I caught this last testimonial here. It wasn't specific about Ford, although it mentioned the Ford engines, but it was about all the 2 liter specifically engines from the different manufacturers, downsized and boosted, and the acceptance of the American public. This was in the free press, and there are many, many other testimonials. It's pretty consistent feedback about this technology when we're downsizing and putting it in its different forms. That's why you can see that we're committed to this strategy at Ford. By 2013, it will be in 90% of our North American nameplates. And going forward, it will be in 1.5 million vehicles per year. But this, obviously, that doesn't come without technical challenges. And I deliberately put these different technical challenges in very random order, and I'm not going to deep dive them. Our esteemed panel here will do that. But it's things like controlling the pressure accurately in the intake, making sure the turbo does not overspeed, does not go over the temperature for which it's specified, ensuring that there is catalyst light-off in time to meet the emissions, waste gate control, a lot of NVH questions, turbo whoosh, tip-out squat, many different names, fancy names different manufacturers have for the same problem. Injector tick with direct injection, high pressure fuel pump noise, condensation in the charger cooler, misfire issues at startup, at high load, etc. The lack of vacuum available to operate some of the auxiliary systems in the vehicle, like a brake booster, or to purge the fuel tank. As we're operating more and more near the peak efficiency of the engine, the available vacuum to operate these systems is not there. So with that, I will be turning it over to our panelists to talk about some of these challenges in different areas. We're going to have Steve McKinley, Dean Tomasik, Audley Brown, and John Juriga. And allow me to introduce our first speaker, Steve McKinley. Steve McKinley is from Honeywell, and I'm going to say just a couple of things here in his introduction. Steve is the Turbo Technologies Vice President of Engineering for the Americas and responsible for all engineering development and validation and product assurance of North and South America customer segments. Based on the increasing demand, as I covered in my talk, for these fuel-efficient products, this segment is experiencing rapid growth with hundreds of new launches in gasoline turbochargers, light trucks, and on and off highway applications. Please help me welcome Steve McKinley.